Brain areas involved in FND that we'll be exploring in this video include the prefrontal and limbic regions, the basal ganglia and thalamus, the anterior cingulate cortex, the tempoparietal junction, or TPJ, and the default mode network and salience network. The SMA is called the supplementary motor cortex, and it's critical in voluntary movement initiation. In FND, the SMA is active during involuntary functional movements, suggesting that movements are generated but without normal conscious agency. The clinical link explains why patients experience movements as happening to them, not by them. Both the basal ganglia and thalamus show abnormal connectivity with frontal and motor areas, which suggests disruptions in motor gating and initiation pathways. The clinical link can produce tremor, dystonia, and gait problems. The temporoparietal junction between the parietal lobe and the temporal lobe involved in sense of agency and integration of body awareness. With abnormal activation, it leads to patients misattributing internally generated movements or symptoms as outside their control. Clinical link: I didn't make my leg give way, it just happened. The anterior cingulate cortex normally links motivation, emotion, and motor control. As it's hyperactive in FND, the overengagement of motor and emotional loops is created. Clinical link may help explain symptom variability with attention and emotion. The brainstem autonomic circuit. Dysregulation of the midbrain and brainstem networks tied to autonomic arousal. The clinical link with the brainstem autonomic circuit overlaps with POTS, dizziness, and functional fainting. The default mode network, or DMN hub, includes the ventromedial prefrontal cortex, which leads to impaired regulation of limbic activity or emotional activity, making symptoms tied to stress and emotions. The salience network, involving the amygdala and anterior insula, is overactive in FND, especially in response to emotional or threat-related stimuli. The amygdala, a threat valence detector, provides key input to the salience network.